Alright, so this video we're going to look at finding probabilities, and we have a binomial distribution. Alright, so let's look, or a binomial experiment. So let's look at the features of a binomial experiment. There's a fixed number of trials denoted by n. Okay, so there's a certain number of things you test. The n trials are independent and repeated under identical conditions. Alright, so the trials are independent. That means the outcome of one trial does not have anything to do with the outcome of the other trial, of another trial. And each trial, well, just like it says, the conditions are identical. Each trial has only two outcomes, a success or a failure. A success we denote using the letter S, a failure the letter F. And for each individual trial, the probability of success is the same. The probability of success is denoted by P. The probability of failure is denoted by Q. And Q is 1 minus P. And the central problem of a binomial experiment is to find the probability of R successes out of n trials. Okay, so there is a formula that you can use. So if we have the probability of R, okay, and we have n trials, but we want to know the probability of R successes. The formula is combination n choose R times P, the probability of success, raised to the R, times Q, which is the probability of a failure, raised to the n minus R. Okay, so that's a formula you can use. In this video, on the first problem, the first part of the first problem, I will use this formula. And then after that, we're going to use the table, the binomial table, to look up these probabilities. All right, so let's get started on our first example. All right, so it says in a particular region, 30% of deer are female. In a random sample of 8 deer, find the following probabilities. Exactly 3 are female. Okay, so we want to know in a random sample of 8, find the following probabilities. So we have 8 deer. If we choose 8 of them randomly, what's the probability that 3 of them are female? So we want to know the probability that R is equal to 3. Okay, well, remember in our formula, combination n choose R times P to the R times Q to the n minus R. That's the probability of R. Okay, and in this case, n is equal to 8. That's the 8. P is equal to 0.3. 30% are female. That's 0.3. Q is 1 minus 0.3, which is 0.7. All right, so all we do now is just plug it into this formula. So that's combination n choose R times P, which is 0.3 raised to the R, times Q, which is 0.7 raised to the n minus R, so the 8 minus 3. And then you'll have to punch this into your calculator, and we get 0.2541. So that would be our probability. Okay, now let's do the same thing here, but let's look up this in the table. So remember, n is 8, P is 0.3, and R is 3. So if we come over here to our table, Okay, so here's a table. Here's n. Okay, and I know on this table it has an x here. Some books use x, some use r. In our case, we use a r. Okay, and it's the same thing. Okay, it's no different. Okay, we're using r instead of x. Okay, so here's n. So we have to look for where n is 8. Well, on this part of the table, this one just goes down to 6, but we can continue on to another table. Okay, and so you can see here is n equals 8. This right here, they use an x, but I'm going to use r. Okay, all right, so to look this up, we go to where n is 8 and r is 3. Okay, and then p, this is p, this line up here, that's 0.3. And so you can see where 3 and 0.3 intersect. That's at 0.254. And you can see the table rounds it to 3 decimal places. In our answer we got what, 0.2541. So, that's using the formula, and here's using the table. Actually, the entire answer when you plug it into the formula is 0.25412184. Okay, and from this point on, we're going to use the table to find the probabilities, and I'll show you why in the next part of the problem. And get this. Now let's go ahead and leave the R there. Okay, so now let's look at this one. Okay, we want to find the probability that less than 5 are female. Okay, less than 5 are female. So we're looking for the probability that R is less than 5. So that means that we can get 0 females, 1 female, or 2 females, or 3 females, or 4 females. Okay, and let me show you why we'll do the table instead, because this, now notice the 5 is not included because it says less than 5. So this is the probability of 0 females. Okay, well, let me write the R in there. Or the probability of 1 female, or the probability of 2 females, or the probability of 3 females, or the probability of 4 females. Okay, so if we use this formula up here, we would have to use this formula for each one of these. We would have to do this formula 1, 2, 3, 4, 5 times. Okay, so you can see how it can be kind of tedious to use the formula. So let's go ahead and use the table. So we'll go to where n is equal to 8, p is equal to 0.3, and then we need the probabilities when r is 0, 1, 2, 3, and 4. So let's go to the table and get these values. Alright, so here we are at the table. So we have n is equal to 8, okay, p is 0.3, and we need the probabilities for when r is 0, 1, 2, 3, and 4. So that is going to be this value when r is 0. We need it when r is 1, 2, 3, and 4. So we'll add all of these values up. Okay, so let's go ahead and write these down on the other page. Okay, so these are each one. So let's go back to our problem. And so remember, for r equals 0, that was 0.058 plus, and then when r is 1, 0.198 plus, and then when r was 2 was 0.296 plus, when r was 3 was 0.254 plus, and when r was 4, 0.136. And then we'll add all of these up and we get 0.942 is our probability. Now the other thing that I want to mention here is that, let me erase this, is that you see this little section here, all of these add up to 1. Everything in this section adds up to 1. Everything in this section adds up to 1. All the numbers in each section add up to 1. Okay? All right. Now let's go to our next part. At least 6 are female. Okay? So at least 6 are female. So that means either 6 or 7 or 8 are female. Okay? So that's the probability that r is greater than or equal to 6. And so that's the probability that r equals 6 plus the probability that r equals 7 plus the probability that r equals 8. See, we only go up to 8 because that's our sample, 8 deer. All right, so now we'll go to the table and look these up. Okay, remember, n is 8, p is 3, and we have to look them up for r equals 6, 7, and 8. All right. So here's n equals 8, p equals 3, so we're on this column, and we need the probabilities when r is 6, 7, and 8. So that's 0.010, 0.001, and then 0.000. So let's go back to our problem. And for 6, that was 0.010 plus, and then for the 7, 0.001 plus, and then the 8, 0.000. And then when you add those together, we get 0.011 for our answer. Okay. All right, so let's look at the next one. At most 2 are female. At most 2. So that's either 0 or 1 or 2. Okay, the 2's included here. So that's the probability that r is less than or equal to 2. So that's the probability that r equals 0, or the probability that r equals 1, or the probability that r equals 2. Okay. Now we can go back to the table and look it up, but you know we've done that, and I already have r equals 0, 1, and 2 up here. Remember, we looked them up for this one, but this went from 0 to 4. We're just going from 0 to 2. So instead of going to the table and looking it up, which I've already showed you how to do that, we're just gonna copy these down since we already looked them up. So for r equals 0, that's 0.058. For r equals 1, that was 0.198, and r equals 2, 0.296. All right, so we get 0.552 as our probability. All right, so now let's go to the next one. And it says exactly 5 are male. Okay, so this changes. Okay, this right here, 0.3, that's the remember, P is the probability of a success. So 0.3 is P, and P represents a probability of success that it's female. Okay, so what this does when it says that are male, well, now the probability of success is a male. So if the probability that it's female is 0.3, then the probability that it's a male is 1 minus 0.3, which is 0.7. So now P becomes 0.7. Okay? Because see, our probability of success has changed from female to male. So the probability that R equals 5, so we'll go back to the table and look this. Okay, so remember, N is equal to 8, P is 0.7, and in this case, R is 5. So let's go look that up. All right, so now we're here where N equals 8, R equals 5, but remember this time, since we're finding the probability of a male, that was 0.7. So we're over here on 0.7 now. So if we look over here, 0.7, and I'm sorry, 5, if we go over here to 5, and then we go to the column where P is 0.7, our probability is this, 0.254. Okay, 0.254. So this probability is 0.254. All right, and I do have one more, but I'm not going to do this one. The main thing with this for the male, I just wanted to show you how the P changes. Okay, and then, you know, everything else is the same. Okay, at least 5 are male, so that means 5 or 6 or 7 or 8. So if we want the probability R at least 5, that's R is greater than or equal to 5. So that's the probability that R equals 5, or the probability that R equals 6, or the probability that R equals 7, or the probability that R equals 8. But just remember, when you go to look these up, you have to look it up in the column where P is 0.7. Okay, just like we did for this one. All right, so let's go to the second problem. All right, so here it says you are taking a 6-question multiple choice quiz. Each question has 5 answers, of which only 1 is correct. Assume you guess on all 6 questions. Find the following probabilities. Probability you answer exactly half the questions correctly. Okay, well, if there's 6 questions, half of them would be 3. So we want to know the probability that R equals 3. All right, so in this problem, N is equal to 6. There's 6 questions. And P, okay, well, what's the probability of getting a question correct? Well, if there's 5 choices and only one's correct, then that's 1/5, which equals 0.2. So P is 0.2 in this case. Okay, so let's go to the table and look this up. Okay, and notice this table is N equals 8, 9, 10, and 11. Okay, so we'll need to go to the other page. All right, and we'll need to go where we're at 6. Okay, here's R, here's N. Okay, and we want r equals 3. We need r equals 3. So here's r equals 3, and we have to go to the column where p, which is this along the top, is 0.2, which is right here. So 3, and then we go over here to 0.2. That's this value. Okay, let me zoom it in so you can see it. So it looks like it is 0.983. I guess that's what it looks like. I know it's not a very good, not too clear, but looks like it's 0.983. So our probability here is 0.983, and this would be your answer. Okay, so I read the table wrong. Well, I mean, I read the table right, but the numbers weren't that clear. It's actually 0.0 0.082. That's what that number should be. It's this number here, but that number is 0.08, and I know this table has a 3. I looked at it in my statistics book, and it's a 2 instead of a 3. But you get the idea, okay? I just want to make sure you know how to look this up. And as far as these go, I'm not going to do these because we're up around 22 minutes. You know how to do this. You answer more than 2 questions correctly. I mean, we can go ahead and write it out. More than 2 questions. So that is probability that r is greater than 2. The 2 is not included. Okay, so that means you're going to either get 3 questions correct, or 4 questions correct, or 5 questions correct, or 6 questions correct. And then you would go look each of these up in the table where n is 6 and p is 0.2, and you would look for r equals 3, 4, 5, and 6. Okay, and then you answer at most 4 questions correctly. And see, we only go up to 6 here because that's what n is. Okay, so you answer at most 4 questions correctly. So that's the probability that r is less than or equal to 4. So that's r is 0 questions correctly, or 1 question correctly, or 2 questions correctly, or 3 questions correctly, or 4 questions correctly. And then you would look each of these up. Okay. All right, so I hope this video helped. I know it was kind of long, but I think we covered everything. And in this last problem here, the main thing I was wanting you to see here is, if you notice in this problem, they didn't come out and give you P like they did in the first one. They said P was 30%, 0.3. In this one, you had to figure out what P was. Okay, they gave you, there's 5 answers and 1 is correct, so we had to calculate P in this one. Okay, so I think I've hit just about everything you would come across for the binomial. So I hope this video helped. Don't forget to like and subscribe, and check out my other videos. Thanks.